Going on, guys? This is my last video on complex number series. I made 7 videos, 7 parts. This is the 8th one. This is the last one. Okay, now let's go ahead and see some questions. We have seen some factor related complex number in my last video. I'm gonna go ahead and continue on that. Let's say we have a question like this: x is equal to 4 plus 3i and 4 minus 3i. How can we solve this? Before, we have just seen just one number, x is equal to 3i, something like that. Let's say we have something with a number. How can we solve this? To do that, again we have to do the same approach for the previous one. What we did, when we have just 3i alone, we move it with x. So x minus 3i is equal to 0, like something like that. For this one, we had to do the similar thing. We had to move everything to one side, like x, and here whatever we have plus, if it's plus here, it's going to become minus with x. So this is going to be x minus 4, and if it's plus 3i, minus 3i, and we put a bracket. And for the second one, we do the same thing, like x here plus 4, so this is going to be minus 4, and if it's minus 3, that's going to be plus 3i, and we equate this one to 0. And now to continue this one, we have long method and short method. Now let's look at the long method first. To do the long method, what we have to do is we have to just FOIL it, like multiplying everything, x times this, and x times this, then negative 4 times this, negative 4 times this, negative 4 times this, then we have to do negative 3i times this, 3i times this, and 3i times this. Now let's go ahead and do that. Now x times x is x square. I use a different color so we don't get confused. X times x is x square, and x times negative 4 is negative 4x, and then x times 3i is 3xi plus 3xi, and then negative 4 times x is negative 4x, and negative 4 times negative 4 plus 16, and then negative 4 times 3i, that's negative 12i. And then lastly, we have negative 3i times x, that is negative 3xi, and then negative 3i times negative 4, that's negative 12i, and then negative 3i times positive 3i, negative 9i square. Now let's see whether we have any terms that cancels. Here I have a 3xi, and here I have a minus 3xi, so these two cancels. And then what else we have? We don't have anything else cancelling, so we can just add this and see the final value. Okay, now x square minus 4x minus 4x minus 8x, and then we have 16, just a number, 16, and then we have minus 12i minus 24i, and here we have 9i square. I square is negative 1, so negative 9 times negative 1, that's positive 9. And here we have two numbers, 16 plus 9, 25. So this will come up to x square minus 8x plus 16 minus 24i plus 25. I think I made a mistake here. Minus here we have minus 4 plus 3i, that is negative 12i, and minus okay, let's see, negative 3i, and then minus 3i times minus 4, that is positive. Minus 3i times minus 4 is positive, so this one should be positive, and these two cancels. So this therefore this 24i doesn't exist. That's a mistake here. That's a mistake. So we are just gonna have x square plus, well, let me get rid of this, x square minus 8x plus 25 plus 25, because I made a mistake by putting negative sign in front of 12i. That is positive, because negative 3i times negative 4, that's positive 12i. So this is the long way to do that. Now let's see the short term method. This is the final answer. Now short term method is basically, here as you see, we have x minus 4 minus 3i and x minus 4 plus 3i, and if you carefully notice, we have a conjugate. You have to see it through, like we know that imaginary number is always attached with I, so this is the imaginary number, right? But these two are real numbers, so x minus 4, and you can see the conjugate here. X minus 4 is a real number minus 3i, and x minus 4 real number plus 3i. So we have a conjugate right here, and whenever we have a conjugate, we can just square the first and last terms, like x minus 4 square and minus 3i times plus 3i, that's minus 9i square. We can always do that for conjugates. So this is going to become just x minus 4 square minus 9i square, and if we simplify this one, we know that we are going to get x square minus 4x minus 4x and plus 16, and minus 9i square. I square is negative 1, so negative 1 times negative 9, positive 9. 16 plus 9, 25, so we will get x square minus 8x plus 25. This is the short method to do this. You can see we are getting the same answer, but here few steps, because we are realizing this is the conjugate, so we can simplify like this. Now let's look at some other problems. Let's get rid of all these things. Okay, now let's say we have a question like this. X is equal to 5 minus 2i and 5 plus 2i. Again, we have to do the same thing, like we have to bring everything together to x, so the sign will change. If it's plus 5, it's going to be minus 5. If it's minus 2i, it's going to be plus 2i, and we put this one in a bracket. And for the second one, x, here plus, so it's going to be minus, and here plus again minus 2i, and that's equal to 0. And here you can notice the conjugate again. X minus 5 is a real number, x minus 5 is a real number, 2i is an imaginary number, 2i is an imaginary number. Only the middle sign changes, so it means it's a conjugate. So whenever we have conjugate, we can just directly multiply this one by this one by this, and write them. So x minus 5 square and minus 2i square, that's equal to 0. Here if we expand x minus 5 square, this is going to be x square minus 5x plus 25, and then 2i square. I square is negative 1, negative 1 times 2, that's going to become actually 4i square, because 2 times 2, 4, so 4i square. Negative 1 times negative 4, that's plus 4. So we are going to end up getting x square minus 10x plus 29. You can go ahead and try it in a long method as well. You will get the same answer. Okay, now let's try another problem. Let's say we have a question like this, that's asking x is equal to square root of 7 plus 3i and square root of 7 minus 3i. How to solve this one? Again, same thing. If we have anything outside of x, we move it with x, so it's going to be x minus square root of 7. If it's plus, minus. If it's plus, again minus 3i, and then this is in a bracket, and the next one x here plus, so this is going to be minus here, and here minus, this is going to be plus here, 3i, that whole thing is equal to 0. Now again you can realize the conjugate here. This one is a real number, and in between we have, this is imaginary, in between we have a sign change, so this is a conjugate, so we can multiply this one with this one with this, and write them. So this is going to be x minus square root of 7 whole square minus 3 times 3 9 I square, that's equal to 0. And again if you expand this one, this is going to be x square negative square root of 7x negative square root of 7x, and then we are going to get square root of 49, that's going to be equivalent to 7, and then minus the I square is minus 1, so minus 1 times minus 9 plus 9. And if we simplify this one, we are gonna get x square minus square root of 7x minus square root of 7x, that's minus 2 square root of 7x, and then 7 plus 9, we are gonna get 16, and that's our final answer. Okay, now that's all in this, and I'm going to show you about sum and product. We can calculate the sum of products of the real roots we get. There is a simple way and a long way as well. Now I'm going to write the general form of a quadratic formula. Let's say we have the quadratic formula. General form is ax square plus bx plus c, that's equal to 0. Now how can we calculate the sum of the roots? Sum of the roots are basically we can calculate simply by negative b over a, and the product of the roots can be calculated simply by doing c over a. Now let's look at an example. Let's say we have a question x square plus 36, that's equal to 0, and here what is the a value? A is 1 because ax square, and b, what is the b value? Here we don't have any x, so it means 0x, and plus c is in our case 36 is equal to 0. Therefore what's the sum? Sum is going to be negative b is 0, so 0 divided by 1, we are going to get 0. What is the product? Product is c over a. In our case c is 36 and a is 1, so this is going to be just 36. Now let's go ahead and prove this one. Okay, now let's go ahead and prove this one. To prove this one, what we do is we just expand, like x square plus 36 is equal to 0. So if we write it in terms of x, we know that if x square is 36, then x square is going to be equal to negative 36, and if you square root a negative 36, we are going to get 6i, because we are square rooting a negative number, so we are going to get I as well. So this is going to be x plus 6i. There are two possible answers, plus 6i and x minus 6i. That's equal to 0. Therefore x is equal to negative 6i or plus 6i. Now we are going to calculate the sum. What we do, we just add them. So if you add negative 6 and plus 6, you will get 0. Plus 6i minus 6i, that's equal to 0. So we are right in this case. We found out we verified this one is right. Now product, we just multiply them. So 6i times negative 6i, that is 36i square, negative 36i square. I square is negative 1, so negative 36 times negative 1, we get positive 36, and this we verified the product is right. So you can try for many different things, you will get exactly the same thing as we seen in the equation. Now let's try some other problem in this. Okay, let's say we have a question like this. Let's say the question is asking the quadratic formula given by x square minus 4x plus 29 is equal to 0. What is the sum? Sum is negative b over a. In our case b is negative 4, so negative 4 divided by a, that is 1, we are going to get just 4. And then product is c over a. C is 29, a is 1, so that's going to be just 29. You can go ahead and do the long way. For this one, this is not a perfect square, so you have to use the quadratic formula to find out the roots and solve them. Let's go ahead and do that. So the quadratic formula is x is equal to negative b plus or minus square root of b square minus 4ac divided by 2a. In our case, b is negative 4, so this is going to be negative 4 right here, and then plus or minus negative 4 square minus 4 times a is 1 and c is 29. C is 29 divided by 2 times a is 1, and if you simplify this one, 4 plus or minus 4 square is 16 minus 29 times 4, that gives us 116 divided by 2, and then 4 plus or minus 16 minus 116, that's negative 100 divided by 2, and 4 plus or minus, if it's 100 we know that square root of 100 is 10, but if it's negative 100 this is 10i, okay, and divided by 2. So we are going to get 4, if we write it in a standard form, this 4 over 2 plus or minus 10i over 2. Standard form is basically a plus bi. A is the real number, bi is the imaginary number. Now we got it in that pattern. Now let's go and continue that one right here. I use a different color so we don't mix it up. Here 4 over 2 is 2 plus or minus 10 over 2 is 5, so 2 plus or minus 5i, and here we have two answers. X is equal to 2 plus 5i, and also x is equal to 2 minus 5i. Now let's go ahead and check the product and sum. Sum is basically we just try to add these two numbers together. If we add them, sum is equal to 2 plus 5i and then plus 2 minus 5i, and here you can see 5i cancels, therefore the sum is going to be 4, and here we got 4, so this is right, we verified this one. Now product, we just multiply them. So for product, 2 plus 5i multiplied by 2 minus 5i, and here you can see this is a conjugate. Whenever we have a conjugate, we can directly multiply this one with this one, this one with this one, and we can get the final answer. 2 times 2, 4, and then 5i times negative 5i, that's negative 25i square. I square is negative 1, negative 1 times negative 25, that's going to be positive 25. Positive 25 plus 4, we are going to get 29, and you can see the product also right, we verify the product as well. And that's how we do this kind of problems, and this is my last video on complex numbers. I'm done with this. I'm going to do different videos, but for this series, this is the end. And thanks for watching this video, and I hope you guys find this video helpful, and don't forget to subscribe my channel. See you guys in the next video.